Public cloud, DevOps, infra as code, FinOps, hybrid cloud, containers, serverless. Do you hear these words very often and wonder if someone could explain the relationship of these things to you in very simple terms? In this video, we want to tell you the story of cloud, but without any jargon. We will ensure that no hi-fi fundu words are involved here. So, if you want to understand what the hype is all about, why does every enterprise have cloud migration in their top agenda these days, and why you should understand cloud irrespective of your current role, then this video will really benefit you. Let's start from the very basics. If you are new to this area, some quick intro for you. You need a server to run any software, be it a web application, a database, a backend process generating your monthly bill, or a media server that stores your video files, right? Think of a server like a big computer, a rectangular box, right? You can imagine, which has got a good amount of CPU and memory or RAM, right? Many years ago, enterprises used to have their own servers. Depending on the money they had, they either maintained their own physical buildings that contained these servers, or they rented a portion from a service provider. These buildings were called data centers. So basically a big building which had a lot of such servers. So think about a big enterprise with whose actual business is manufacturing consumer goods. They build and sell in many countries around the world. Of course, to run all their IT systems, they need to host it somewhere, right? Which means they need servers. So they choose to build a data center of their own. Let's say they built it somewhere in California, on the western side of the US. After a few weeks, they realize that they need redundancy, right? Because one location could be prone to natural disasters. So they built another data center on the eastern side of the US. This consumer goods company allocated a considerable annual budget to run these data centers. So they built a whole IT team to support all their data center operations and constantly tried to improve their ways of working. At the same time, in the parallel world, there were other businesses who were building software products. There was a company that transformed the book buying experience for the users. Another company changed the way people used emails, maps, or watched online videos. And one more company that sold the operating system, which is used on most of the personal computers around the world. Now, all these companies had a very big business of their own, and they were managing a lot of their own servers to ensure that their product is available to people around the world at a large scale. That too, without any interruption and with really good performance. Over time, these companies, Amazon, Google, and Microsoft, mastered their ways of managing the data centers and decided to offer their services to other businesses as well. This was the start of public cloud and the three big cloud providers. Before we take the story further, you need to understand about a technology called virtualization. Yes, virtual machine is related to that. In a data center, if you have a physical server with 64 CPU and let's say 2 TB RAM, you can use virtualization technique to divide it logically into multiple virtual machines, let's say of 4 CPU and 64 GB RAM each. Not only that, virtualization also allows you to turn off a virtual machine when it is not in use and use its underlying CPU and RAM for another virtual machine. This was really a game changer. Let's understand this from a business point of view. Cloud provider could now sell a part of a physical server to one customer and another part of the same physical server to another customer. Moreover, they could now offer a pay for what you use model, right? Or it's also called pay as you go. It means that let's say a customer 1 pays only for 10 hours when they need a particular VM for 10 hours, right? Let's say a customer one is using a particular VM from 1 p.m. to 11 p.m., for example. After this, the resources of this particular VM would be repurposed for another customer, let's say customer 2, and so on and so forth. So you get the model, right? The last bit here is the ability to automate. Cloud providers gave the ability to create, stop, and delete these virtual machines just by an API call. In simple terms, think of it like a command from your laptop going to the cloud provider and which actually results in the creation of these resources. So, packed with this innovation, cloud providers built multiple data centers around the world and started offering their services to other businesses. You might be thinking at this point, why can't our consumer goods company do the same thing and make use of this virtualization technology and achieve all of these benefits themselves, isn't it? Well, they tried it. Virtualization was adopted by the IT companies in various businesses, but they were still limited by the overall physical capacity. They were able to optimize the resource utilization within their data center, but they couldn't handle the large spikes during the peak business activities. It's because of the fact that the number of servers they could physically procure was still limited, right? They cannot just go ahead and buy unlimited number of servers. One more thing to understand here is that the type of technical talent which these cloud providers were able to attract was far superior than what a consumer goods company could do. Hence, the cloud providers were able to innovate a lot faster and offered far better services with clear SLAs and lower costs. Alright, so you now understand the business model to start with. In very simple terms, it is sharing of physical resources by different customers, but with a clear interface. Cloud providers started with this initial offering. Businesses around the world were already having a hard time managing their data centers and IT staff as it was not their area of expertise. Take the example of our consumer goods company. They excelled in manufacturing and shipping fantastic soaps, shampoo, and detergent, but releasing the next version of their software was not an easy task for them. Businesses around the world got convinced about giving away some of their IT responsibilities to a cloud provider and found this model to be useful as they need not manage their own data centers anymore. It also resulted in reduction of IT staff on their end. Another advantage was the scaling possibilities that come with the public cloud. Our consumer goods company was now able to use many more VMs during the launch of their new product and released those resources when the load went down. So, was it only about running your VMs in the public cloud instead of your data center? No, it wouldn't have come this far if it was just the movement of VMs. Cloud providers also started offering managed services in the other areas like databases, storage, queue and notification services, monitoring, streaming, etc. This was a very big shift, and it took time for businesses to accept this change. Let's understand this with a simple example. Earlier, when a database server was required, it meant creation of a virtual machine first, then a Linux engineer did all the hardening at the OS level, and then handed it over to a database administrator. Now, DBA took their own time to go ahead and actually install the database software. They configured the necessary monitoring and backups after that. This whole thing took a couple of days, even in the best case scenario. Now, when we move to the cloud, with a managed database service from the cloud provider, this database server creation becomes a 30 minutes task at max. Moreover, it doesn't require DBA level expertise anymore. And it could be triggered by an API call as part of the bigger automation. There are clear benefits, and the organizations which actually cared for their time started adopting such managed services from the cloud provider. Today, we have managed services for most of the building blocks of your architecture. be it database, caching server, log monitoring, pub/sub, data streams, etc. There is a school of thought which suggests to remain away from cloud providers' managed services. But we will discuss about that in a separate video. That's a big discussion actually. Go ahead and hit that subscribe button if you want to get notified about that video. Cloud providers have their data centers around the world. Take example of AWS. They have the concept of regions. These are the geographic locations around the world where they have multiple data centers. Please understand, multiple data centers in every geographic location. So you can see different AWS regions on the screen. These regions are further composed of 3 or more availability zones, which are physically isolated from each other but connected via their private network within a region. An availability zone further contains multiple data centers. All of this is done to provide increased redundancy to the customer. As a customer, you can choose the level of redundancy that suits your workload, right? Please understand that increased redundancy means increased cost. Hence, customers should understand the offering from the cloud provider and choose carefully. But the good news is that in many cases, the cloud providers give you a high level of redundancy built as part of the service by default. Look at AWS S3 bucket or a DynamoDB table. When you upload a file to an S3 bucket, 6 copies of this file actually get stored across 3 availability zones within a region. That is 2 copies per availability zone. And you get this feature with zero extra engineering. You are not doing anything extra. You just go ahead and upload your file. Rest everything happens at the background on its own. I talked about provisioning the servers via an API call. In simple terms, it's about provisioning resources in a remote data center by executing a command from your laptop. Cloud providers implemented a lot of engineering in exposing every function as an API. So it is possible for you to go ahead and create a virtual machine, stop it, restart it, or terminate it altogether remotely just by a command. Not only this, you can go ahead and do finer, more granular actions as well, like increasing the disk size on your VM or changing even the disk type altogether to a high performing disk type. All of this is possible. Infrastructure as code, or IAC, is the practice of managing your infra with the help of code. A customer can write down a simple human readable file or a template which specifies all the cloud resources that need to be provisioned. It will also contain the required attribute values for those resources. So you can go ahead and write a template which creates a cloud network, a load balancer, 4 virtual machines, and a database server. And with this template, you can create multiple application environments on the cloud without making any mistakes. It increases your speed and brings in repeatability. In the cloud world, you do not provision and configure infrastructure manually. It is all done via code, and infrastructure as code is a great help there. But what about the security of our workload? As it says, public cloud. There's a long explanation for this, but in short, I can tell you that things are quite secure on the public cloud, provided that you use the given controls properly. Public cloud puts you in the driving seat and lets you configure things to the level of strictness which you actually want. Some of the biggest financial institutions and government departments around the world run their production applications on cloud today. That should be a good enough evidence for you to go ahead and use public cloud. Next, how much time does it take to move our workloads to cloud? It really depends on the size of your workload and also the maturity of your team. Typically, enterprises run some of their applications in their on-premises data centers while they work on migrating more and more to the public cloud. During this phase, you can consider them using hybrid cloud. That is a combination of public cloud and their own private cloud. There are mechanisms available to have a private and fast connectivity between public cloud and your own on-premises data center. Once you establish this, Your public cloud setup just acts as an extension of your own data center. It is as easy as that. So before we wrap up, let's discuss about the most important point. Did the movement to public cloud solve the cost issues for businesses? Yes, it lowered down the cost on the known fronts like no more data center operations, reduced IT staff, and saving on underutilized resources, etc. But cloud pricing is a bit difficult to understand for many people. It does not follow a fixed static model. Cloud pricing is dynamic in nature and works out to be quite granular. The cost depends on many factors and differs from one service to another. Cloud facilitates easy provisioning of resources. So, if your team doesn't understand cloud pricing very well, they may end up provisioning unnecessary resources and increasing your bill in an unexpected manner. This is where FinOps comes in and enforces a framework to adopt the right practices and get the maximum business value out of cloud. Please understand, cloud pricing is not difficult, but it requires an honest attempt from the practitioners to go ahead and learn it in detail. We have a lot of videos on our channel just diving into the cloud pricing. If you want, go ahead and look at it. There are more concepts which I would like to simplify for you, like DevOps, serverless, and containers, etc. So please let us know if this video gave you a conceptual understanding of public cloud at least. If you want to look at the demo videos and a lot of in-depth videos on particular or on any particular topic, you have it in our channel already. Right? If you want to just get started on the cloud path in your learning, please follow our channel. Also look at our website, learncloud.pro. And please, if you want to further follow this, go ahead and hit that subscribe button. We'll see you in the next one. Have a good time. Bye.